All right, everyone. Welcome to today's Cosmic Masterclass. Grab a seat and get comfortable because in this explainer, we are going to tackle literally the greatest unsolved mystery in modern science. We're talking about something that surrounds us, something that fundamentally shapes our entire existence, and yet it is completely invisible. So let's just dive right into it. To kick things off, I want you to picture a really simple, everyday action. You take a baseball and you launch it straight up into the air. What happens? I mean, we all know the basic rules of physics, right? The ball goes up, it gradually slows down, hits its peak for a split second, and then it falls right back down to Earth. And why does it do that? Because of gravity. Gravity is kind of the ultimate rule maker of the cosmos. It's always pulling things together. And for decades, scientists applied this exact same logic to the entire universe. They assumed the gravity from billions and billions of galaxies would act like a brake, slowly pulling everything closer together over time, or at the very least, slowing down the expansion of space. Honestly, it was a perfectly logical assumption.
But what if you threw that ball into the air and instead of slowing down, it started rocketing upward? What if it just kept getting faster and faster the higher it went? That would be completely terrifying, right? Well, on a cosmic scale, that is exactly what is happening right now. The universe's expansion isn't slowing down at all. It is accelerating. Something invisible, something we cannot see or touch, is violently pushing galaxies apart.
So here is our lesson plan for today's explainer. 1. The gravity rule breaker. 2. Discovering the invisible force. 3. What exactly is it? 4. Dark matter versus dark energy. 5. The universe's hidden ingredients. And finally, 6. Will the universe rip?
Starting with Part 1, the gravity rule breaker.
Let's look at how the universe managed to break the oldest rule in the physics playbook. To really grasp this, we have to rewind nearly 14 billion years, all the way back to the Big Bang. After that massive event, space itself just started expanding in every direction. And like we talked about, for decades, astronomers assumed that the collective gravity of all those billions of galaxies would act like a cosmic brake pedal, gradually slowing this expansion down. But then, 1998 rolls around. Astronomers made a discovery so shocking it completely flipped our understanding of the cosmos upside down. The expansion was actually speeding up. Something totally unknown was overpowering gravity itself.
Moving on to Part 2, discovering the invisible force.
So how on earth do you catch the universe breaking a fundamental rule like that? Well, it wasn't easy, but it is a brilliant example of the scientific method in action. Astronomers started observing these very specific, incredibly bright exploding stars. They're called Type Ia supernova. And the coolest thing about these specific stars is that they always explode with nearly the exact same peak brightness. Because we know exactly how bright they should be, we can use them as sort of cosmic tape measures to calculate exactly how far away they are. But when scientists actually compared those distances with how fast the galaxies were moving, the math was just totally broken. The galaxies were way farther away than they were supposed to be. It was undeniable proof that an invisible force had been pushing them apart for billions of years. And guys, this wasn't just some tiny rounding error in a spreadsheet. In 1998, two completely independent research teams reached the exact same mind-blowing conclusion at the same time. The universe was accelerating. This was such a monumental paradigm shift that it actually earned the researchers the 2011 Nobel Prize in Physics. Literally overnight, it became one of the most important discoveries in the entire history of astronomy.
Part 3. What exactly is it?
All right, so this brings us to the billion-dollar question that every single one of you is probably thinking right now. What exactly is this stuff? If you're taking notes, definitely write this down. Dark energy is an unknown, invisible force acting on empty space that causes the universe's expansion to accelerate. But here's the little secret that scientists don't always advertise. Dark energy? It's literally just a placeholder name. The honest truth is that nobody actually knows what it is. We just know what it does. It doesn't hold galaxies together. Instead, it acts on the vast, empty voids between the galaxies.
So the real head-scratcher is trying to figure out how nothing can actually push. Let's look at the leading theory right now. First, quantum physics suggests that empty space isn't actually empty. Even in a perfect absolute vacuum, space itself possesses these tiny amounts of invisible energy. Second, we already know the universe is expanding, which means more space is constantly being created. So follow the logic here. If space has energy and you suddenly have more space, well, you get more of this mysterious energy. It's like a cosmic runaway train. More space equals more energy, which pushes galaxies apart even faster, which creates even more space, creating even more energy. Scientists are still testing this, obviously, but it is a fascinating way to explain why the acceleration keeps speeding up.
Part 4. Dark matter versus dark energy.
Okay, before we go any further, I absolutely need to clear up the biggest point of confusion for anyone studying astronomy. People constantly mix up dark matter and dark energy. I get it, they sound similar, but they are completely different beasts. Dark matter creates gravity. Its entire job is to pull galaxies together. Dark energy, on the other hand, accelerates expansion. Its job is to push galaxies apart. Let's use an analogy to make it stick. Imagine the whole universe as a giant city. Dark matter acts like the physical steel beams, holding every skyscraper and building together so they don't just collapse. But dark energy acts like a relentless invisible bulldozer, slowly pushing every single building farther and farther away from each other. One pulls, the other pushes. Together, this invisible tug-of-war literally shapes our entire universe.
Part 5. The universe's hidden ingredients. Prepare yourselves, because this statistic is easily the most astonishing thing you will learn all year. Think about everything you have ever seen. Everything humanity has ever interacted with. The stars, the planets, the trees outside, your smartphone, the mountains, literally your own body. All of it combined makes up only 5% of the universe. Just 5%. That's normal matter. Dark matter makes up roughly 27%, and dark energy, an absolutely staggering 68%. Think about that. Almost 2/3 of the entire universe consists of a mysterious pushing force that we do not understand at all.
There's a great quote for this. Imagine reading a book where only one page out of 20 explains the story. Just let that sink in for a second. That is exactly where human knowledge is sitting right now. The vast majority of our own universe is entirely hidden from us, which honestly means there is so much left for your generation to discover.
And finally, Part 6. Will the universe rip?
That brings us to the grand finale of today's lesson. What does all of this actually mean for the end of time? Is the universe going to rip apart? Scientists are currently looking at two main hypothetical futures. First, if dark energy remains constant, the universe will just keep expanding forever. Galaxies will drift infinitely far apart, and billions of years from now, the night sky will simply go entirely dark as everything fades beyond our observable horizon. But there is a second, much more dramatic theory. If dark energy actually grows stronger over time, it could eventually overpower every single force in nature. It would tear apart galaxies, then stars, then planets, and finally it would rip atoms themselves apart in an event they call the Big Rip. Now, don't panic. There is absolutely no real evidence that this will definitely happen anytime soon. It is really just one hypothetical mathematical future.
So, as we wrap up this explainer, I want to leave you all with one final thought. We know dark energy exists because we can measure its effects. We know it makes up 68% of reality, but its true identity? That's still a totally blank page just waiting to be written. The next time you look up at the night sky, I want you to remember this. The greatest mystery in the universe isn't hiding inside some distant glowing star or swirling galaxy. It is hiding right there in the pitch black, seemingly empty space right between them. Thank you so much for joining today's lesson. Stay curious, keep asking the big questions, and who knows, maybe one of you will be the one to finally crack the mystery of dark energy.